This video is on completing the square, and we will work through the problems on page 5 in your note packet. So if we look at number 13, it says solve the equation. In chapter 6, we learned how to solve by factoring. However, if we take a look at this example here, I can't think of anything that multiplies to -5 and adds to 8. So therefore we can't factor this particular problem. So one method that will allow us to solve this is to complete the square. And remember that completing the square allows you to find a number such that you can rewrite the problem so that you have a quantity that is squared. That's the purpose of completing the square. So in your notes, we have our steps. So step 1 is divide each side by the quantity of A, but our A value here is 1. So we're going to go ahead and skip step 1. Now we're going to isolate the constant. Remember that this is optional. I'm going to put OP for optional. So step 2 is we're going to add 5 to both sides. Now step 3 says divide the coefficient of x, so our b term, so we're going to take this number right here, and we are going to divide 8 by 2. Okay, now step 4, we're going to take that number there, so we're going to take the 4 we just got from here, and we're going to square it, and we get 16. And that is the number that we're going to insert into the equation here. Now whatever I do to one side, I have to do to the other side to keep it still equal. I'm going to simplify here. 5 plus 16 here is 21. Now the whole purpose of putting this number here is that now you can factor this as x plus 4 times x plus 4. So remember, originally we couldn't factor this problem here. But now that we put the 16 right here, now we can factor it. And not only can we factor it, we could write this as x plus 4 to the second power. That is exactly what we want when we complete the square. We want it to be the same thing times the same thing. So right here, what two numbers multiply to 16 and add to 8? It's 4 and 4, and it's always going to be the number from step 3 right here. So if you're detailed in your work, all you have to do is look right here as to what multiplies to 16 and adds to 8, that number that goes here. Alright, so let's go ahead and continue here. So now we're going to solve this problem using the square root. So whatever we do to one side, we have to do to the other side. So remember our rule right here, 2 goes into 2 once, so this is going to undo. And then we have x plus 4 left here, but we don't need this parenthesis here because the exponent is no longer there. And remember, when we put a square root into a problem, we need plus or minus. And then we're going to subtract 4 to both sides, and we get x equals, and I like to put the -4 in front so nobody gets confused and thinks that the -4 is in the radical. Okay, so then before we circle our answer and say we're done, we just need to make sure that the square root of 21 can't be simplified. And if I make a factor tree here, there is no perfect square number that goes into 21, so it is as simplified as possible. So this is our exact answer. And then go ahead and put that answer into your calculator and make sure you get to the hundredths place. 58 hundredths and -8.58. So this would be your approximate answer, and this is your exact answer. Problem number 14 on page 5, it says to solve the equation. So a couple chapters ago, we learned how to solve by factoring. So what two numbers multiply to 20 and add to 10. However, if we try to do that here, we will find that no such numbers exist. So we can't solve this by factoring. So if we can't solve by factoring, then another method we can utilize is completing the square. So to complete the square, we're going to divide, step 1, we're going to divide by the leading coefficient. However, there is a leading coefficient of 1, so we can skip step 1. Step 2 is optional, so I'm going to go ahead and do it. So I'm going to subtract 20 to both sides. And done with step 2. Step 3, divide the b value, so the coefficient of the x, divide it by 2. So we get 5. Step 4 now, square that number. So we're going to take that 5 we got here and square it, and we get 25. So that is the number that we're going to put on both sides. So we're going to insert a 25 here, and whatever we do to the one side of the equation, we do to the other. Now, the purpose of doing that is that now you can factor that left side of the equation here. So what multiplies to 25 and adds to 10? It's always going to be this number here from step 3. So x plus 5 times x plus 5. Now, the whole purpose of doing this is that these are always the same. And since they're the same, we can write it as x plus 5 to the second power, because the 2 is telling us that there's 2 of them being multiplied. So now we can continue solving by square rooting both sides, and remember what comes along with that is a plus or minus, so we're left with x plus 5 on the left and plus or minus the square root of 5 on the right. And now to get this x by itself, we're going to subtract 5, and we get x equals, and I like to put the negative 5 in front so there's no confusion that it's not part of the radical. And then before we circle our answer like I just did there, we just need to make sure that the number in the radical cannot be simplified. And the only thing that goes in, that multiplies to make the square root of 5 is the square root of 1 times the square root of 5. So those are prime. We can't, there's no perfect square other than 1 that goes into 5. So this is our final answer. So this is called the exact solution. And then if you go ahead and put it in your calculator, make sure that you get negative 2.76 and negative 7.24. So those are approximate answers to the nearest hundredth. Alright, example 15 on page 5. First step is divide each of the sides by the leading coefficient. So whatever's in front of the one with the higher exponent, we're going to divide everything by a negative 1. Okay. Step 2 is optional. Isolate the constant, which it already is. The one without the variables all on one side. So we can skip step 2. Step 3, divide the coefficient of x, so we call that the b value. So this negative 3, we're going to divide it by 2. And since 2 doesn't evenly go into negative 3, we're going to leave it as negative 3 halves. Okay, done with step 3. Step 4 is we're going to square that negative 3 halves. So we get 9 fourths. So this is the number. I'm going to move this over a little bit here and leave a spot right here. This is the number that, if we write it in here, is going to make this problem factorable. So we're going to, whatever we do to one side, we have to do to the other side. So we're going to simplify here. 10 plus 9 fourths is 49 fourths. Instead of writing it as a decimal, I recommend leaving it as a fraction, because if you didn't have a calculator, it would be easier to have it as a fraction. So I would put this in my calculator, If you were doing it by hand, remember you need to make 10 have a denominator of 4 so they match. And therefore that's how we get 49/4. So now that we put this 9/4 into the problem, what multiplies to 9/4 but adds to this -3 right here? So that could sound confusing to people, but if you look right here, this is going to be that number. X minus 3/2 and x minus 3/2. When we multiply that, we will get that above trinomial there, because -3/2 times -3/2 is 9/4, which is that. And then if we add them, -3/2 plus -3/2 is -6/2, which is -3. So it works. Okay, so now that we have added that number into the problem, now we can factor this. That was the point. We were able to factor this, and now we can rewrite it as x minus 3/2 to the second power. Now we can square root both sides. Don't forget we need a plus or minus. And then we're going to add 3/2 to both sides. And we have x equals, we're going to have a positive 7/2 plus 3/2. And x is equal to a negative 7/2 plus 3/2. So 7/2 plus 3/2 is 10/2, which 10 divided by 2 is 5. So we get x equals 5. And then -7/2 plus 3/2 is -4/2, which equals -2. So we have our two solutions, 5 and -2. Number 16 on page 5 of your note packet. The first step is to divide each side by the leading coefficient. So we're going to divide this whole side by 2 and this whole side by 2. So when we do that, we get 0 divided by 2 on the right. And then when we divide by 2, we're actually dividing each term by 2. So we're going to get x squared plus 2x minus 3 equals 0. So done with step 1. Step 2, isolate the constant. This one is the optional step. You could leave that on that side, but I'm going to go ahead and move it over. Alright, step 3. Take the b value, which is the coefficient of x, so take this 2. Divide it by 2, which is 1, and done with step 3. Step 4 is to square that value, so we get 1. So that's the number. If we put it on the left hand side, now makes this factorable as 1 times 1 is 1 and 1 plus 1 is 2. So whatever this number is going to go in parentheses here twice. And the whole purpose of doing that is now we can write it as x plus 1 squared equals 4. So now we can take the square root of both sides, and we're left with x plus 1 on the left. And remember, when we put in a square root, there's a plus or minus. Square root of 4 is 2. And now to get this x by itself, we're going to subtract 1. So one solution is positive 2 minus 1. And our other solution is negative 2 minus 1. So we get that x is 1, and we get that x is -3.